Good morning all my dear students. Today I am here with a topic of class 12, which is a very important topic of class 12, that is the second chapter of chemistry, which is solution. In this topic we will be covering various various of the topics. One is solution, then types of solution, then how to find out the concentration of different solution. So first of all, focusing on these three topics, first of all let us learn why we have this solution chapter in our chemistry. What is the reason of having this solution chapter? So in our various life activities we are seeing that different components are reacting with one another to form a new component. So for studying all the solutions and solute particles, we need to learn this chapter, and this is necessary for the stoichiometric analysis and for the stoichiometric calculations which are very important for the pharmaceutical company, for various laboratories. So rapidly starting with the first one, with the first term, what is called solution. All of you have gone through this term solution in your previous classes of class 9 and 10. A solution is a homogeneous mixture of two or more substances. It can be two or it can be more substances forming a single phase. That is forming a single phase. This is a solution is a homogeneous mixture of two or more substances forming a single phase and dispersed in a molecular media. Suppose I have taken sugar and salt, then I have prepared a sugar solution, that is a solution in which sugar and water is present. So this is an example of solution. So from the word solution there again comes two terms which are solute. Another one is the solvent. Now all of you have previously learned about the solute and the solvent. What is called the solute and what is called the solvent? Solute means the percentage of the component which is present in the solution in a smaller amount, that is called the solute, and the percentage of the solution which is present in a larger amount, that is called the solvent. So solvent is present in a larger amount and solute is present in a smaller amount. They combine together to form the solution. For example, there are different types of solute. They can be salt, they can be sugar, they can be other substances. And solvent, there are various types of solvent. They can be water. Water is called the universal solvent. Many of you have known water is called the universal solvent. Why water is called the universal solvent? Because in water all the solutes can dissolve. So that's why water is called the universal solvent. So it can be water, it can be alcohol, and many other things. So I hope all of you have gone through the term what is called solution, solute, and the solvents. So here I've tried to write some of the types of the solution which are solute and solvent. There are various types of solution. It can be gaseous and gaseous. So if I am drawing this here for your benefit so that you can properly see the what is I am writing, solute and solvent. So here the solute is gaseous and the solvent, it is also gaseous. Can you find some example of this type of solution? We can find this type of solution in our surroundings. It can be air, clean air which we are taking. This clean air is a mixture of gas and gas. Then nitrogen mixture, nitrogen, this is also a mixture of two gases. Then carbon dioxide and hydrogen. So carbon dioxide and hydrogen, these are the two gases. When they mix together, then they form a solution. So coming to the next one, gaseous and liquid. What do you mean by gaseous and liquid solution? So in this case, gaseous, this is the solute. So this is the solute, and liquid, this is the solvent. So in this case, a gas is mixed in a liquid, so to form the solution. So what will be the examples? Example can be CO2 in water. All of us take aerated drinks, cool drinks, Coca-Cola, all these things are taken. So have you noticed when the cork of the bottle is opened, some gases are evolved? Why these gases are evolved? These gases are nothing but carbon dioxide. This carbon dioxide is dissolved in water under high pressure and low temperature. Carbon dioxide is not generally dissolving in water. In general, this is not found dissolving in water. But when under great pressure, higher pressure, when it is dissolved in water, then it forms a solution. So in this case, the gaseous solute is the carbon dioxide and the water is the solvent. So this one is the second one. I hope all of you are writing all these things in the book, but still it is better if you copy these things. Then the next one is gaseous and solid. So gaseous and solid. So in this case, gaseous, this is the solute, and the solid is the solvent. So what type of things can be found in this type of solution? Gaseous means, so hydrogen. This hydrogen, when dissolved in palladium. Palladium is a metal. When hydrogen is dissolved in palladium, then it forms an amalgam type of solution. So this type of solution is a solution in which gaseous substance is dissolved in a solid substance. So next coming to liquid and gaseous. Liquid plus gaseous. So in this case, the solute is the liquid and the gaseous is the solvent. So can you find some example of this kind of solution? We see in our surrounding, this is moisture here. When do we find this moisture here? In the rainy season. What is happening in the rainy season? There are lots of humidity. The humidity level is very high in the rainy season. So one question you may have learned in class 9-10 in the Madhyamik standard, that why in the rainy season when we give the clothes to dry up, they don't dry up easily, rather than in the summer season they dry up very easily. Why? Because the humidity means the water content present in the air in the rainy season is very high. For this reason, the extra water from our clothes cannot cope up to enter into that gaseous component. So moisture here is an example of solute in which a liquid is dissolved in a gaseous component. Here the liquid is the water vapor which is dissolved in the air. So this is an example of this type of solution. Then coming to the very important one, and which is covering the whole topic here, is the liquid and the liquid. Liquid and liquid. Our chapter is based on this thing only. So on example of liquid and liquid, here the solute is the liquid. Similarly, the solvent is also the liquid. Solvent is also the liquid. One example of this, aqueous solution of ethanol and water. Ethanol plus water. This is an aqueous solution in which the solute is liquid and also the solvent is liquid. So this is this example is very important for this chapter. And there are lots of examples also covering the various types of solution, solid and liquid. Solid plus liquid. In this case, the solid is the solute and the liquid is the solvent. This is very common. Solute sugar, then water. This is very common one, in which the solute is the sugar and the solvent is the water to make a sugar solution or salt solution, like this type. And another very uncommon one is the solid plus solid. We know that all the types of solution, when the word solution comes to our mind, then we think that it is a liquid, but not, this is not the fact. Solution can be formed with solid and solid. Solid and solid. For example, in this case, the solute is the solid as well as the solvent is also a solid. For example, bronze. This is a nothing but a solution in which bronze, in which copper is mixed with zinc. Then another example can be copper and silver to form sterling solution. This is an amalgam in which a solid is dissolved in a solid to form a solution. So this topic has been covered. This whole chapter has been covered up to this. So this I have completed the types of the solution. Then coming to the next topic. How can we find the concentration of a solution? There are various ways and lots of formulas and lots of terms will be coming in this topic. And the maximum numerical sums are coming from this topic, which are the methods of expression of expressing the concentration of a solution. So the first term which will be coming is the percent concentration. So these are the terms by which we can express the concentration of a solution. Percent concentration, which is divided into three categories. One is mass percent, another one is mass volume percent, next one is volume percent. What happens in mass percent? What happens in mass percent? Mass of the formula of this mass percent is mass of the solute. Mass of the solute, it will be divided by mass of the solution. So we know that in a solution, solute and solvent are there. So how to find out the mass percentage? We have to find out by this formula into 100. As we are finding out the percentage, we have to write down, we have to multiply with 100. So in mass percentage, mass of the solute divided by mass of the solution into 100. So here W by V. W, we have taken W, the mass of the solute, and V, the mass of the solution, that is the volume. Then coming to the second one, mass volume percent. It can be expressed as mass of the solution divided by the volume of the solution. Volume of the solution into 100. So here mass volume means mass of the solution. You have to take the weight on mass of the solution, then total volume of the solution. Then if we multiply by 100, then it will come the mass volume percent. Lots of numerical problems are given from this formula. If you wrap up this formula, then you can easily solve the numerical problems which will be given in your board exams. And at least one numerical problem is given from this type of questions. So then coming to the next one, all these things are covered in percent concentration. So the next one is the volume percent. What happens in the volume percent? How can we calculate? Volume of the solute divided by volume of the solution into 100. So here two volumes are taken. Volume of the solute divided by the volume of the solution into 100. So these are the three parts which are covered under percent concentration. I hope all of you are writing. Then coming to the most important thing, which is the normality. What happens in normality? What do you mean by normality? This is a new term. This is denoted by capital N. Normality means the number of gram equivalent dissolved in 1 volume of a solution. That is the number of gram equivalent. It is written as, or mathematically it is expressed as number of gram equivalent divided by the volume of the solution. So the unit is gram equivalent per liter inverse. So number of gram equivalent divided by the volume of the solution, this is going to be our normality. So, and whether this term is dependent on temperature or not. This term depends on the temperature. Why this is depending on the temperature? Because volume is there. This volume is depending on the temperature. So the whole term will be depending on temperature. So what are the advantages of normality? Normality depends on the reaction. What type of reaction are going on, we can find out with the help of the normality. So I think up to this is clear. So next, going to the second part, which is molarity. What do you mean by the term molarity? This is denoted by capital M. So molarity means mass of the dissolved liquid. Mass of the dissolved solute per liter of the solution divided by the gram molecular mass. Mass of the dissolved solute per liter of the solution. In 1 liter of the solution, how much solute is dissolved divided by the gram molecular mass. This is coming our molarity. And this molarity is also dependent on temperature. Molarity, this is depending on temperature. This is dependent on temperature. Depending on the temperature. And this molarity is used for the for finding out the various concentration in the solution, for different stoichiometric analysis. These things are used. Then another important term will be coming after this, that is the formality. What do you mean by the term formality? Formality is generally used for the ionic solutions. All these terms are used for the, all the other terms are used for the other type of solution. All the terms type of solution, this formality is used for the ionic solution only. So for what will be the definition of formality? Formality is gram molecule mass, gram molecular mass, or it can write gram molecular mass of ionic solute per liter of the solution. So how much gram molecular mass of the ionic solute is present in 1 liter of the solution, that is coming as formality, and it is denoted by F. It also depends on temperature. Is it depending on temperature? Yes, it depends on temperature. So it is used for finding the concentration of the ionic solids and annexed solutions. So I have covered the 4 terms: percentage concentration, normality, molarity and formality. And now the rest term, the another term is coming, which is called the molarity. What do you mean by the term molality? Don't confuse this L and R. One is molarity, another one is molality. What do you mean by molality? It is the number of moles of a dissolved solute in 1 kg of the solvent. How many moles? Number of moles of dissolved solute. Number of moles of the dissolved solute in 1 kg of the solvent. Here the solvent is taken in kg. So how many moles of the solute is dissolved in 1 kg of the solvent, that is termed as molarity. And molality, temperature dependence of molality, this is not depending on temperature. Not depending on temperature. Not depending on temperature. Here, because why it is not depending on temperature, these moles, number of moles and this weight of solvent, these are not depending on the temperature. All these are the intrinsic property of the body. These are not depending on the temperature. If volume is there, then it will be depending on the temperature. As these two terms are not depending on temperature, so the whole term will not be depending on temperature. So one question can come, which term cannot be dependent on temperature, and that one is coming molality. Molality is not dependent on temperature. So I hope all of you have understood up to this. So now we will be doing some numerical sums on these 4 topics which I have covered. So these are all the sums. These are from the NCERT. So I am writing down the sums. Percent concentration of an aqueous solution of HNO3 is 47.5 Wb. Find the normality of the solution. What will be the normality? This term we have to find out. So first let us understand the question. What will be the question? Percentage concentration of aqueous solution of HNO3, nitric acid, is 47.5. So what is the percentage concentration? This is 47.5. We have to find out the normality. So what will be the normality? What is the formula? So we can write down in 100 centimeter cube of 47.5 W by B HNO3 solution contains 47.5 grams of HNO3. So we know that this is a monobasic acid. So what will be the molecular mass, gram molecular mass? So the gram molecular mass will be hydrogen 1, nitrogen 14, then oxygen 3 into 16. So what will be coming? 1 plus 14 plus how much? 48. Then it is coming 15, 48, 15, 73. Sorry, 63. 63. So this is the gram molecular mass of HNO3. So up to this, I hope up to this you have written. Therefore, the normality of the solution will be, therefore, the number of gram equivalent of 47.5 gram of HNO3 is equal to, this is given 47.5, and what is the equivalent weight? This is 63. So if I divide this, it's coming 47.5 divided by 63, it's coming nearly 0.7, it's coming 0.754, it's coming roughly, it's coming 0.754. This is the number of gram equivalent. So this is the number of gram equivalent. So the normality will be 0.754 by 100 into 1000. So coming, so it will be 7.54. This will be the normality. Okay, this is one type of sum which is depending on the normality. We have to find out this type of sums will come in the exam. So first of all, you have to find out the gram equivalent weight, then you have to find out the normality. Then another sum I am writing on the percentage concentration. Calculate the percent concentration of 1.25 normal aqueous NaOH solution. Calculate the percent concentration of 1.25 normal NaOH solution, sodium hydroxide solution. So 1.25 normal solution of NaOH contains, what does it contain? NaOH 1.25 into 40. Why? From where this 40 is coming? Sodium 23, then 16 plus 1. This is coming 40. So from this 40 is coming. The molecular weight. So NaOH in 100 centimeter cube of solution. Therefore, the percentage concentration of 1.25 normal NaOH will be 50. This 50. This is this is coming 1.25 into 40. It's coming it's coming 50. So this is coming 50. So 50 by 1000 into 100. So 0 0 cancel, 0 0 cancel, it will be 5. So the percentage concentration will be 5. So on these two terms, on these two formulas, I have written two sums. Now coming to another topic. Oh, sorry, I have forgotten about the characteristics of the solution. What can be the characteristics of the solution? We are discussing about a solution is a homogeneous mixture. Homogeneous mixture. A solution is a homogeneous mixture. The particles present in this solution are very less. It is 10 to the power minus 5 to 10 to the power minus 7 centimeter. So imagine how much less, how much it is very less, and it cannot be seen with the help of the naked eyes. We have to use strong electron microscope to see these things. So, and here the concentration remains the same all over the particles. Concentration remains the same throughout the mixture. Concentration remains the same throughout the mixture, and this is a single phase system. This is a single phase system. So these are the characteristics of a solution. These are the characteristics of a solution. of a solution. So another term can be covered with this. So do you know when we mix any solute and solvent, then sometimes heat is evolved and sometimes heat is absorbed. Heat is evolved and heat is absorbed. For example, NaOH plus H2O. In this case, heat is evolved. Heat is evolved, and NH4Cl plus H2O, heat is absorbed. So when the heat is evolved, then it is called an exothermic reaction, and when the heat is absorbed, that is called an endothermic reaction. So these are the two terms covered. So next, coming to another thing, I want to discuss about the difference between the molar solution and molal solution. What is the difference between the molal solution and molar solution? What is molar solution? Molar solution is 1 liter of the solute is dissolved in 1 liter of the solute is dissolved in 1 liter of the solution contains 1 mole of the solute. This is called molar solution, and molar solution is 1 kg of the solution contains 1 mole of the solute. These are the two difference. One is dependent on temperature, this one is dependent on temperature, this one is not dependent on temperature. This one depends on temperature. Next one is not dependent on temperature. So after this I have covered, so we can easily wrap up quickly what we have covered. We have covered what is called solution, how many types of solution are there, what are the types of the solution, then the concentration. I have done 2 sums on the molarity and percent concentration. Then I have discussed the difference between the molar solution and molal solution. So in the next class we will be continuing all the topics, which are many topics are left. With that, one is the Henry's law, Raoult's law, vapor pressure, osmotic pressure, reverse osmosis. I request all of you to go through the topics so that you can easily understand when I discuss in the class. So today class is up to this over. Wish you all the best and stay safe at home. Thank you.